Welcome back to part 3 of working with rational indices, where we are going to do example 3, factorize. So in part A, we're asked to factorize 3 to the power of x plus 4 plus 3 to the x. Now, to deal with this particular problem, it looks a little bit nasty, but once again, it's nothing that we haven't seen before. So the way in which we're going to deal with this particular guy is we're going to have a look at the common factor and take that out. And simply looking at this, I can see that the common factor is going to be 3 to the power of x. So if I pull 3 to the power of x out of the first one, what I'm going to be left with is 3 to the power of 4 plus 1. Like so. So in this case, what we can see is that the answer, or the factorized form of this, is 3 to the power of 4 plus 1, or times 3 to the x. And if we wanted to go a little bit further, we could go 3 to the power of x. Then we can evaluate 3 to the power of 4, which is equal to 3, 9, 27, then 81 plus 1. And then we find that it's 3 to the x times 82. So we could write it either as 82 times 3 to the x, or we could simply leave it in this form here. Whichever way is the most expedient to represent it. Now, going across to 3 to the power of n plus 3 plus 27. Well, again, this is just one step onwards from what we were at in the previous one. So we've got 3 to the n plus 3, and notice what is special about the number 27. And you may have guessed it in that 27 is a multiple of 3. If we factorize it, we're going to get 27 divided by 3 is going to be 9. And then factorizing 9, it will be 3 times 3. So what we indeed find is that the factors of 27 are 3 times 3 times 3, which can be rewritten as 3 cubed. Now what we can do is we can reorder the first expression and say it's 3 plus n, the power, and then 3 cubed. Then we can pull out the factor of 3 cubed. So we're left with 3 to the power of n plus 1, and therefore we're going to be left with 27 times 3 to the n plus 1, like so, and that could be rewritten as 27 times 3 to the n plus 28, if we so like it, or once again, we could simply leave it as this form here. Going down to part C, we are poised with something a little bit trickier as well. So we want to factorize this. So what we can say is, we can say 3, 5n plus 3, 2n. And we can break it up a little and then go 3, 5, no, we won't go 5, we'll go 3n plus 2n plus 3, 2n. Then we can pull out a common factor of 3 to the power of 2n, which leaves us with 3 to the power of 3n plus 1. And then this would be the simplest form we could get to right here. So this would be its factorized form. Going across to D, we're really testing our memory from topic 2, polynomials. And have a look at this. We've got 9 to the power of x minus 16. Now you may have picked up on this form already, or it might not be apparent just yet, but imagine we can go 9 to the x minus 16, and we can write it as, notice 9 and 16, they're perfect squares, so we can write it as 3 to the power of 2x minus 4 to the power of 2. And then remember, we can use this rule called the difference of two squares. So a plus b, a minus b, is the same as writing a squared minus b squared. In this case, our a is going to be this guy there, and our b is going to be this guy here. So rewriting that out, we're going to get 3 to the x plus 4, and then 3 to the x take 4, and this would be our simplified form right here. Going down to part E. Going down to E, we're looking at something that's not so intuitive either, but nonetheless, it's something we still can do with the tools that we have learned already. And let's go 2 to the 2x minus 2 to the x minus 2. And then let's do something a little bit funky and go let a equal 2 to the x. And what this is going to do for us is we're going to get a squared minus a minus 2, like so. And then notice we can factorize this. We can factorize this as a squared plus a minus 2a minus 2. Then taking out common factor, we can go a plus 1. Then we can take out minus 2, a plus 1. And then we find our factorized form is a plus 1 times a minus 2. And then recalling, but a equals 2 to the x, we can simply rewrite this as, scroll down a little, rewrite this as 2 to the x plus 1, 2 to the x minus 2. And this would be our factorized form right here. So not necessarily easily apparent to see, but nothing we haven't done before. So we'll leave it there for now, and then in the next video we'll look at jumping in section 4.